Alrighty, we're going to keep practicing some of that trinomial factoring, just with a couple more twists than we saw in the previous video. Those are all kind of straightforward, just following the basic rules. And there's a couple weirder ones and a little bit of review in this video. So let's hop to it. X squared minus 9x plus 18 equals 0. We're also going to be talking about getting the actual solution, right? The factors are just a way to get the solution in a nice, easy way. So let's go over here. X squared minus 9x plus 18. X squared minus 9x plus 18. So I want two numbers that multiply to the last one, and they also need to add to the x term. And instead of the last and the middle term, I really should be saying the constant term and the x term, right? Or the exponent of one term. Anyways, let's get to it. So two numbers that are going to multiply to a positive 18 and add to a negative 9. So let's do the factors of 18. 18 is going to have 1 and 18. It's not going to be that. It's going to be 2 and 9. It's not going to be that, right? Because 2 and 9 has to make some sort of 7. So then what about 3 and 6? 3 and 6 can make a 9, right? 3 plus 6 makes 9. We just need the two numbers to multiply to a positive, but then add to a negative. Well, this is the case where it's going to have to be a negative 3 times negative 6 makes a positive 18. And then if I have a negative 3 plus a negative 6, so negative 3 times negative 6 makes a positive 18. But if I do negative 3 plus negative 6, that is actually going to get me that negative 9. So that is our answer over there. We're done. Moving on to the next question because there's a couple to go through. Oh, wait. Not moving on to the next question yet. Sorry. So this was originally with equals 0, right? And equals 0. I'll bring up my calculator for a second just to show, like, if I graph this guy. So if I graphed x squared minus 9x plus 18, and then I hit the graph mode here, it looks like it's hitting at this number right over here, 1, 2, 3, and then 4, 5, 6. It looks like it's hitting at 3 and 6. And it's to the right, so it's a positive 3 and a positive 6. But in my factors, I had x minus 3 and x minus 6, right? So again, the whole reason we're doing factoring is to be able to find these roots where the quadratic equation hits the x-axis algebraically. But this factoring, it shows a negative 3 and a negative 6 equals 0, even though on the calculator it looks like my roots are at positive 3 and positive 6. But that's because these numbers over here are not my answers, right? The negative 3 and the negative 6, these are, how I put it into the factored form, but really, you're looking for what x would be in this equation. And if I want the whole left side to equal 0, I have to make one of these terms equal 0, right? So if I put x equals 3 in, and I plug that in here, 3 minus 3 will make 0. That'll make the whole left side 0. And then the other side would be, well, if I made x equals 6, 6 minus 6 equals 0. And so that's kind of just the idea of getting the solution again, right? So here is the factored form, we'll call it. Factored form. But now in this video, we're also going to just make sure we're practicing getting, hey, these are the roots or the solutions. You need to flip the sign from your factored forms to get your solutions. Okay, that was enough new stuff. Let's keep going. X squared plus 5x plus 4. X squared plus 5x plus 4 plus 5x. Oh my goodness, that 5 plus 4 equals 0 is what they gave us. They want the solutions. Do they want the solutions or the factored form? They want solve the quadratic, so they actually want the solutions. Good. Okay. So two numbers that are going to multiply to 4, but they also add to 5. So 1 and 4, 2 and 2, and that's it. Those are all the factors. 1 and 4, 1 and 4 add up to 5, right? So my factored form is going to be x plus 1 and x plus 4. 1 times 4 will make 4. 1 plus 4 will make 5. We're good. And then to get the solutions, because this is equal to 0, you just got to say, well, I flip the signs, right? If x was negative 1, this first binomial would become 0, and then multiply times whatever makes it 0. And then if x was negative 4, it would 0 that binomial out. So here are the solutions. This is the factored form. Let's keep going. I want to get through all 6 of these examples, and maybe even these 2 for a little bit of practice. All right. It's a little bit different. It's a little bit weirder, but it's really not that crazy. X squared equals 11x minus 28. X squared equals 11x minus 28. Okay. Now, you cannot do your factored form until you have all of your terms in a trinomial. They need to all be together on one side. So I can do this either by moving this x over there, except we don't know how to deal with a trinomial unless it's just a plain old x squared in front. If I move this over, it'll make it a negative x squared. We don't know how to deal with that yet. We haven't had a lesson on that yet. So what I'm going to do is just move these guys over. So I'll do minus 11x to both sides. Right, there's my center. That cancels there, and I'm going to have x squared minus 11x equals negative 28. And I got to get everybody onto one side so that I can do my factoring that I know. So I'll do plus 28 to both sides. And that will then become x squared minus 11x plus 28. And when these cancel, they don't just cancel to become nothing. I mean, they do, but nothing we represent as 0. And now we can go about actually factoring this. Let's get to it. So 2 numbers that multiply to a positive 28 and add to a negative 11. I think I'm going to have to list the factors out. Ooh, sorry for bumping the mic. So 28, it is, obviously 1 and 28. 2 has to work because it is a even number. 2 and 14. 3 doesn't work. 21, 24, 27. No, 3 doesn't work. Sorry. 4 should work. It's going to be 4 and 5, 6, 7. 4 and 7. Yes, 4 and 7. 5 doesn't work. 6 doesn't work. And then we're up to 7. We're already done. Okay. 1 and 28 are never going to add to an 11. 2 and 14 will make a 12 or a 16. Close, but not quite there. It's got to be the 4 and the 7. Now, what can I do to these guys, to the signs here, such that 4 and 7 will multiply to make a positive 28 and add to make a negative 11? Well, if I did positive 4 and positive 7, 4 times 7 is 28. But positive 4 plus positive 7 is not a negative 11. If I make them both negative, though, negative 4 times negative 7, double negative will make a positive 28. And negative 4 plus negative 7 makes that negative 11. This is our factored form. And now to get the solutions, you just got to say it, right? So this is my factored form. And to get the solutions, you just got to say, all right, well, it's going to be x equals positive 4 or x equals positive 7. You just flip the signs that you have from your factors. That's why we factor, to be able to get that situation where we can flip to get the solution. All right, let's keep going. A couple more. That was 11. Let's move on to 12. I think I have enough room before having to throw this page out. K squared plus 15k minus 56. K squared plus 15k minus 56 minus 50. Oh no, equals negative 56. Equals negative 56. Now, as of now, you can do it, but for right now, we're just going to say I never want to put a negative sign or anything in front of the k squared, the square term, so I have to move this 56 over. So as negative 56, I'll do plus 56 to both sides. That will cancel, and I'm left with k squared plus 15k plus 56 equals 0. And now we just got to do two numbers that multiply to 56 and add to 15. So I'll do 56 is going to be 1 and 56. I don't think so. It's going to be 2. And if you ever get to a big number like 56, you can't do it all in your head. That's okay. Just use a calculator, right? Yeah, I can do 56 divided by 2 to see if it works out. So 56 divided by 2, so it's 56 and 28. So I can say 28 here. Ooh, sorry for smacking the camera. And then I can try 3, right? Does 3 work? Well, I can do 56 divided by 3, and it doesn't work. It's a decimal. Sorry, 3 doesn't work. 4 should work. Should 4 work? 4 should work. 4 should work, and we're going to try it out. So I'll try 56 divided by 4 makes 14. Okay. 5 definitely does not work. 6 definitely does not work. 54 and then 60. 6 definitely does not work. 7, I think 7 does work. What's 56 divided by 7? It is 8. So 7 and 8. And then I'd get to 8 and 7, so we're done. We know we found all the factors. Great. And which one of these, sets of pairs is going to be able to add up to 15? 1 and 56, no way. 2 and 28 is going to be 30 or 26. This will be 18 or 10, no. 7 and 8 does add to make 15. Positives all around, so it's just going to be positives. K plus 7, K plus 8 equals 0. And that means that this is my factored form, but the solutions are K equals -7 and K equals -8. Okay. Let's do these last two, or even just one more to see, and then we'll call it, because I feel like I'm taking a little while on this video. All right, that's done. 3k squared minus 18k minus 21 equals 0. 3, whatever, x squared minus 18x minus 21. Minus 18x minus 21 equals 0. And for something like this, I was saying all along in this video that we don't know how to deal with numbers that are in front. And while there is a way to deal with it, the easiest thing to do is to try and see if there's a way that you can get rid of it. And don't forget, our very first way of factoring from before was the opposite of distribution. So what can I divide out of all of these guys that I can pull out in front of the parentheses? So I'm going to continue this down over here. X squared x and a constant, no variables can be divided out. But all three of these numbers here can be divided by a 3. If I pulled a 3 out from each of these guys, that means I divided a 3 away. 3 divide the 3 out, it's just going to be x squared. Negative 18 divide the 3 out. 18 divided by 3 is going to be negative 6x. And negative 21 divide the 3 out, it's going to be minus 7 equals 0. And now we have a trinomial that's kind of regular with just an x squared term in front. And we can go about figuring out what two numbers, so I know the 3 is still going to be there, what two numbers multiply to negative 7 and add to negative 6. Well, the only numbers that multiply to 7 are 7 and 1, and one of them has to be negative, because if I make a negative here, it has to be a positive there to multiply to a negative 7. Which one of these has to be negative to be the negative 6 when I'm adding? Well, it has to be the bigger one to make it a negative 6. So it's going to be negative 7 plus 1 is going to be my factors equals 0. Now we have the factored form. Even though there's 3's out in front, the only things that are going to make this expression here 0 is going to be if I make x equal to a positive 7 or x equal to a negative 1. So those are my solutions for it. I'll get you started on the last one, and then I'm not going to finish it. You can try to figure it out on your own. 6k squared minus 42k plus 72. 6k squared minus 42k plus 72. And you just got to see, well, what can I divide out of each of these guys? You see the number in front here? You're usually going to want to try to see if I can divide a 6 out of these. So let's do it. we're going to divide a 6 out in front, and it'll be k squared. That's easy enough. And if you're not sure, just grab your calculator, right? 42 divide out the 6 is going to be a 7, so it'll be minus 7k. And then 72 divided by 6, 72 divided by 6 gets me a 12, so then it'll be plus 12 at the end. Let me rewrite this a little bit neater, and then you're going to figure out that last bit, minus 7k plus 12. So here we divided the 6 out from everybody. Once I've got that, you can just plain old factor this. Two numbers that multiply to 12 add up to negative 7. That's it for the practice video here. We saw a couple different ways for how to do trinomial factoring. The plain old-fashioned way, sometimes you have to move things over so that it's equal to 0 and that you have a nice trinomial with x squared, x, and then a number. Sometimes you're going to have to actually start by GCF factoring, take a number out from all of them so that you have nothing in front of my squared term. Yeah, I think this video also went a little long. Sorry about that. Just, there's always more practice to be doing, right?